number 5. So I see that we have the same trig function, but not the same angle. So again, I need to look at those double angle identities and see if I can have a relationship between cosine 2 theta and cosine. Well, cosine 2 theta, we have lots of choices, as we saw before. But this time I'm going to choose that one because it relates cosine to cosine and it doesn't involve sine at all. So I'm going to substitute this in here. And at this point, I want you to continue this problem, see if you can get the answers. This graph is between 0 and 2 pi. It's this curve, and they seem to intersect in 2 points, so you should get 2 answers. And I'm even going to tell you they should be exact answers, meaning they're going to be values on that unit circle that you should know. Problem number 6. We have cosine squares and sine squared, so we have the same angle of x, but we don't have the same trig function. So again, I'm going to go back to cosine squared x plus sine squared x is equal to 1, that Pythagorean identity. And I'm going to substitute that in for there, and that allows me to change everything to sines. I'm going to distribute, and I see that it's quadratic again, and this time I'm going to pull everything to the right hand side because again I like my squared term to be positive. That's just a personal preference. So let's see, if that goes over there, that's going to be negative, and if that goes over there, added to the 2, it's minus 1. So let's see, if I think about this being quadratic, maybe like 3w squared minus w minus 1 equals 0. Can I factor that? No. So that means I'm going to have to use the quadratic formula again. And what does my w stand for? The sine of x. Now my a, b, and c, that's good. So a is 3, b is negative 1, and c is negative 1. So remember, it's negative b plus or minus the square root b squared minus 4ac all divided by 2a. Your interval is between 0 and 2 pi. I graphed this and 2, y equals to 2, and they intersect 1, 2, 3, 4 times. You should get 4 answers. Again, I'm going to let you try to work this one. You need some help. I want you to go back to problem number 2. Refer to problem number 2, where we did the quadratic formula. Thinking about your calculator, be careful, and your calculator should be in radian mode. These next few problems deal with multiple angles. That's going to change some things. We need to be careful. Look at this graph. This is between 0 and 2 pi, and look at your sine wave. You don't just have one of them, you have 2 of them because it has changed that period. Remember that period was 2 pi divided by b. Well, that's b. So our period now for that sine wave is pi, and that's why we get 2 sine waves within the interval of 0 to 2 pi. And when does it equal to 1? In 2 places. Now you probably could just look at the picture and write down the answers, but let's do the algebra to get there. First of all, this, remember, is an interval for theta. So I need the interval for 2 theta. So you just want to multiply those by 2. just stay with me. Right here, I'm going to take the inverse sine of both sides. I have to do this first. When is the sine equal to 1? Well, it's equal to 1. Look at our graph. Okay, between 0 and 2 pi, it's equal to 1 at pi over 2, but this is 2 pi. So I need to go around the circle again, and I would get 5 pi over 2. Now, the last step you're going to do is divide by that coefficient of theta. So if I divide these by 2, I'm going to get pi over 4 and 5 pi over 4. That's pi over 4. That's 5 pi over 4. Be careful. Let's look at this next one. Again, this is graphed between 0 and 2 pi. I've got my cosine wave going, which means I get 2 cycles. Square root of 3 over 2, that should sound familiar. When does it equal? 1, 2, 3, 4 answers. So again, this is theta. So 2 theta is between 0 and 4 pi. I'm going to go through the same steps. I'm going to take the inverse cosine of the square root of 3 over 2. I should know that the cosine is positive in 2 quadrants. Where is that? At pi over 6 and 11 pi over 6. But that's just between 0 and 2 pi. I have to go around the circle again because I have 2 thetas. So I just add 2 pi. The last step I do is divide by 2. All 4 of these answers, 1, 2, 3, 4, fall between 0 and 2 pi. 23 over 12 is less than 2, so I'm within my interval. So when you have multiple angles, you usually have a lot of answers. This time we have all the same trig value, we have the same angle, so this is for x. What's 3x going to be? Multiply by 3. That means we're going to go around that circle 3 times. So this is between 0 and 2 pi. I've graphed that whole thing. When does it equal to 0? 1, 2, 3, 4, 5, 6, 7, 8, 9 answers. Oh my. Hang on, we'll get there. It's not that difficult. You should notice that it's quadratic in nature. So if I substitute w here, so that's going to be 2w squared minus w minus 1. I could factor that, thank goodness. I think that works. So now I'm going to go ahead and write what is w. That's the sine of x. Set that equal to 0 and solve. So I'm going to subtract 1 and divide by 2 and add 1. Yay! No calculator. These are values that I should know. I know the sine is negative in 2 quadrants. When is it equal to negative 1/2? At 7 pi over 6 and 11 pi over 6. And I've just seen my mistake. What was w equal to? Not sine of x, but the sine of 3x. That's my multiple angle where I get all these answers. I apologize. So if I take the inverse sine, I'm going to go back to here and say 3x is the inverse sine of negative 1/2. These are the first 2 answers I get. That would be between 0 and 2 pi, but now I need to go around the circle 3 times. So I'm going to get more answers. So I just add 2 pi to each of these answers and keep going. Then I'm going to add 2 pi to those two answers. Not done yet, because that's 3x. I need to divide all of these by 3, which means all of those denominators become 18. But am I done? No, that's only 6 answers from there. And again, that should be a 3. So I'm going to have 3x equals to the inverse sign of positive 1. Well, when is the sign equal to 1? At pi over 2 the first time around the circle, 5 pi over 2 the second time around the circle, and then go one more time and we get 9 pi over 2. And then what do we have to do? We have to divide by 3. So I'm going to get pi over 6, 5 pi over 6, and then I'd get 9 pi over 6, but I'd want to reduce that to 3 pi over 2. So that's 3 answers, 6 answers. That gives me 9 answers. All of those answers are between 0 and 2 pi. If you would have left these as the answers, that's bigger than 2 pi. 6 goes into 19 more than 2 times. So the correct answers are all 6 of these, 3 of those, 9 answers. So let's start with looking at the graph. I've graphed tangent squared 3x, and I've graphed the line y equals to 1. 4, 5, 6, 7, 8, 9, 10, 11, 12. I need 12 answers. Oh my. Well, that's because that's x, and 3x means I need to go 3 times around the circle. The good news is there's not a lot of algebra. You're not going to have to factor anything here. So we're going to take the square root of both sides. So I have the tangent of 3x equals to positive 1 and negative 1. Remember, plus or minus. Then I'm going to take the inverse tangent of 1 and the inverse tangent of negative 1. Now this last problem is kind of tricky. We do have the same angle as x, but we don't have the same trig function. How can we solve that? Well, you should say, oh, secant. Secant is the reciprocal of cosine x. That's right. Now you have fractions though. So let's multiply both sides by the cosine of x and see what happens. And automatically you should be thinking, oh no, quadratic again. Yes. So just looking at this picture, the good news is that it's between 0 and 2 pi. You have a single angle. So we have the cosine wave and the secant wave, and it looks like they might intersect at the endpoint somewhere, maybe, maybe not. Definitely intersect there. So I'm either going to say 2 answers or 4 answers. So I definitely see this as a quadratic. The question is can I factor it? I'd rather factor it than use that quadratic formula. I think it's easier. And yes, it does factor. Then I want you to go ahead and finish that. You should get exact answers. And there should be 3 answers. So you might look at this, and that is because the 2 pi is not included, so it's not going to be here at the end. And continue that. You can make sure your answers are in radians, and in this case they should be exact. Lots of examples, but you just have to get better at them by practicing.